Okay, let's have a look at adding structure to code. So if you've been writing code so far and you've just opened the editor and you've started typing away, you may have written 10, 15, 20 lines of code and got your program to run. That's great, but as time goes on, those 10, 15, 20 lines will expand and become 30, 40, 50, 60, 70, 80, 100, 200, 1,000, huge number of lines. And it can all get pretty confusing. And as you start to try and understand what you've done and you start to try and add and mod and change it, or explain it to somebody else, or try and tell people about the good bits you've done and allow them to have access to it, it gets very, very difficult. So single big blocks of code like that are not a good idea. We don't really write code like that for real, for a whole raft of reasons. And also it's not the way we would design code. Real good code is actually split up into separate blocks, and each block has got its own clear purpose. In Python we call these blocks functions. If you've done stuff with Scratch before, they're called blocks, and you can create new blocks. If you've done C and things like that, they might be called procedures or functions. In C, procedures and functions are very similar. They just have slightly subtly different purposes. In Python, there are just functions, and that's what we want to talk about now. So one of the most important parts about kind of programming in Python is the design of the code. Now this is what the majority of people are very, very bad at doing. Most people sit down and think, right, I've got to write a program, and they open up the editor and start typing program away. That's the last thing you actually want to do. To write good code, you need to do all of the things that we want to teach in computer science. All of the logic, all of the decomposition, all of the abstraction, all the planning up front before you start writing code. Because when you write the code, you want it very clear in your head what you wish to achieve, and then the only little problem you have is actually creating the code to do it. But when you see most people writing code, the problem they have is they don't actually know what they're doing as they start trying to type the code. And they don't get lost in how to write the code, they get lost in, hang on, what am I actually trying to achieve here, and how do I do it within the confines of this code? So what we do is we don't write a big huge block and split it up. We actually design it the other way around. We start with our overall problem and we sit and think about it with good old pen and paper if need be, or a whiteboard or something like that. Obviously there's lots of software tools that allow you to do this, but you know, pen and paper is as good as any. And we break the problem down into smaller sub-problems. We think about overall what our program needs to do, what we're trying to achieve. We think, okay, to get to that end game, what do I need to do? I need to do A, then B, then C. By doing that, we're breaking our problem down, and this process is called decomposition. It's just a logical way of attacking any kind of problem. Break it down into sub-problems. In our particular case, our sub-problems then become blocks of code in their own right. It might be that some of our sub-problems are too big, and they might need to actually be broken down into other smaller problems. And it doesn't matter if the problems, the sub-problems that we end up with are only ever executed once, we would still put them in a separate block. We hear many people say, oh, you only write functions or these blocks for things that you want to do several times, so it makes sense to create a block and call them lots of times. That's true, but it's not the whole story. It makes perfect sense to create blocks of code that you only ever call once, because it helps us understand the structure of the code. It makes it more easy to read, more easy to maintain, and more easy to kind of write and debug. So just reiterating it, we get our whole problem and we break it down into 3 smaller sub-problems. Notice no talking about coding here. No real care about coding at this stage. I'm just thinking about how I solve this overall problem. And we think about the flow between our sub-problems. Do we need to do sub-problem 1, then 2, and then 3? Or could they go in a different order? It might be linear like that. You know, maybe we need to do sub-problem 2 10 times because of the way the program works. Whatever the data, the flow of instruction is, we want to know what it is. We just make sure we've got that right in our mind. So what we do then is each sub-problem, depending how big it is, becomes a function in Python, and we try and give it a name that describes what that sub-function, that problem, tries to do. Now, in the diagram here, it looks like the flow of code goes from the start straight into subproblem 1, and at the end of subproblem 1 we pass it on to the next problem. Now, we don't actually do it that way because we don't want at the end of each problem to hard code where it goes next, because then you'd be writing subproblem 1 and it could only ever link into subproblem 2 or whatever. So we don't do it like that. The way we actually code it is we come up with an overarching main function, and that main function then calls out other functions. Notice now I've changed the word from subproblems to functions, so I'm starting to use the Python terminology. And you can see here that our program starts and we call our main function to run, and our main function goes and calls function 1. So it passes control into function 1. Function 1 does its job, and then it returns from function 1 back to the main code. Back in our main code, we say, right, what's the next step? I need to call function 2. So we go off and call function 2. Function 2 finishes and it returns back to where it came, which tells me now to go and run function 3. Function 3, we pass control to there, and that returns. And at the end, in this case, I've got a further function 2, and it goes back and it reuses the software in function 2 again, finishes that and passes you back to where you got called from. So our main function is sitting there really on the whole making calls to other functions to actually do the work. We might put a bit of code in the main function, but on the whole the main function should be quite small and read pretty much like English and be the main sub-processes or sub-problems from our initial problem. So it's not like I've drawn on the diagram here. It is decomposition doesn't mean take a big program and split it down into smaller blocks. It is saying though that really decomposition is the smaller blocks acting as if they are one big program. But by creating them as these blocks, we can better control, better maintain, better manage, and better design our software. So we've got all these blocks. When we create these blocks within Python, we use the def keyword. Def stands for define, and then we put the name of the block, in this case block 1, block 2 and block 3. Again, there'll be a colon after it, and our statements, our codes in there, actual lines of program will be indented because they're part of that block. So we call each function from main. When the function ends, it goes back into main from wherever it was called. And how do we get the whole thing going? Well, we actually start by calling the function main. Now, you don't have to call it main, but by default, everybody does. It's kind of one of those unwritten rules. This is the way you code. You can call it Fred if you want, but nobody knows what you're talking about. So by default, it's called main, and everybody uses main. Then you look at somebody else's code, and you know what's going on. So what do we do with main? Well, main is just another function. So we define the function called main, exactly the same way we defined our other blocks. And in main, I'm not showing it here, these should be indented really. If we're looking at the structure of code, should be a colon up here. We call our blocks one after the other or whatever order we want to. We might have a loop within main that goes around and calls them several times. It depends on the structure, what it looks like. And to start our program running, we actually just call the function main. We all know this is a function because it's a main and it's followed by parentheses. So this is the only bit that you'll see in your main program that actually runs directly. It calls the main function and the main function calls all the other functions. So if you've got your mind around that, that's straightforward. The next idea is about data scoping and parameter passing. So if you've written just big blocks of code with none of these functions before, you'll have never worried about variables. You'll have just created them and you can use them anywhere. It doesn't really matter. Once we start creating functions, however, we need to think about where we need access to the various variables. Because variables created within functions are what are called locally scoped. They are only available within that function. Other functions will not have access to variables that are defined in different functions. And this concept of encapsulating the data in the function, holding it together, is crucial to good program design. It forces us to think about what functions do, what access do they need to data to do their job. Now clearly, if everything was completely isolated, we wouldn't be able to pass any information between the functions, and that wouldn't make sense. So we can do. If we want to pass data into a function, then we pass that in during the calling process, and we pass them in as what we call arguments. We've seen this with the print statement, because you put print, open brackets, so open parentheses, and you put some text in there. That's an argument you pass to the print statement, so it knows what to print. And when we define our functions, we can determine what arguments we pass in. If a function goes away and calculates something for us, or gets user input or something like that, the function wants to return that to the main program. So we can also get functions to return values to the main code, and they get returned back to wherever it was called from. And again, we've already seen that with the input function. We call the input function, and the input function returns to us whatever the user typed in. If we want one of our functions to do that, then we need to return that value at the end. Python's quite clever because we can pass in lots of arguments and we can return lots of values. What does it look like when we look at the code? Well, here's a little very simple block. This block has been called block 1, not a very inventive name. So how did we define it? We defined it saying def space block 1. We put parentheses after that, and then we put the variable here, name. What does that tell me? It tells me that when I call block 1, I'm expected to be passed a parameter. And whatever parameter I'm passed, I'm going to store it in a local variable called name. So within my function here, this is what my function does. You'll notice a colon and the indentation. I can use the variable name, so I can print whatever's typed in, or do anything I want with this variable name. At the end of our code, at the end of our code here, we've called the input statement. That's given me value age, so presumably they've typed something in. And notice this function returns the value age to where it was called. So that it returns it out of the code. How do we actually use the block? Well, here we go. When we call the function, here it is, we call in block 1, and we're passing in a variable, or the contents of a variable. In our main program, I've called it user, which presumably is storing some user's name. So this will be representing probably a string. And when I call the function, the string that user is pointing to here is passed into, and name now gets a copy of that string, and it carries on and uses it within the program. When our program ends and it returns the value age, presumably age is, well, in fact in this case I've not converted it, so it's still a string in fact, I maybe should have converted it to an integer in here. It returns the value age. Where does that go? It's returned to the point here where I called it. So the return value becomes the right side of the assignment statement, and whatever value I return is assigned to the variable years old. So we'll see this construct quite often, calling one of our own functions with a name and then the parentheses, maybe passing data in. Don't forget, you've not always got to pass data in. Maybe our functions don't need any arguments passed in. And possibly, if our function returns a value, you'll see it like this: the function definition, the function name here being assigned back to a variable, and that's because the return value pops up here and is assigned back to the variable. So that's a quick kind of whiz on functions. Just a dead quick look at some code that actually encompasses this. Just going through the structure that we talked about here. Here is our main function. So we've got a definition of main here. There's our name for it and our parentheses colon. You can see everything's indented. What does main do? It calls a function called print welcome. Where's that? Here it is. Here's our print welcome function. And this, what does it do? Funnily enough, it prints the welcome information. What's our program then do? It goes to run a function called run quiz, and it looks like run quiz returns something to us which we store in a variable called score. So if we're going to have a quick look at run quiz, here's run quiz, math score, it's got some loop going from 1 to 10, generate some random numbers, ask some questions in here. If the user answer is the same as the correct answer, print correct and increase the score by 1. Okay, I'm not going into that in detail, I don't care, I can see roughly what it does, I'm not worried about the context. At the end, what does it do? It returns the math score. So it returns this variable that started at 0 that seems to go up by 1 every time they get a correct answer. Gosh, I wonder what that is. Obviously it says score. So that is returned back to our main calling function because of this assignment statement here, and it's stored in main in a variable called score. What do we then do? We call another function called print results, and we send it the value that's in score. What does print results do? Print results, whatever we've passed in is put into the display score, and here's our if and elif statements that we've looked at earlier in the course. If the score was 10, right top marks, bigger than 7, great effort, and so on. So obviously this is kind of printing out overall what the results are and some comment for them. Okay, so that's the main function, but that doesn't run it, remember, that's the definition. Here are all our 3 functions. How does the code actually start? Because all we've seen here is the definitions. Well, the more sharp-eyed amongst you will have noticed, here we go, right at the bottom of our code is our call to main. So it's not until the code gets down here and hits this command main does it go up and actually run our main function. And now the program actually starts. And you can see by using this structure of having a main function and sub-functions, I've not got lost in the detail of what the hell's going on in this code. It's really straightforward. What does our code do? Prints a welcome message, runs a quiz, and prints the results and exits. What do each of these do in turn? Well, I can go and have a look at the detail. But this structure encoding really makes things clear. It makes it easy to explain, easy to manage, easy to change our quiz. If I know I want to run it for a different number of iterations, I know exactly where I need to go in my code to change that. Okay, hopefully that's convinced you that this structured programming and creating functions and calling them all from main is the way to go, because basically it is, and we'll be doing more of it as we progress through these various courses. Okay, thanks, bye.